Hello, everyone. Welcome on in. We are going to be doing a nice Friday stream today. Maybe we'll make it happen. Maybe we won't. We have a plan for today. Today's plan, we're going to be building a machine learning, a deep learning framework from scratch. Well, mostly from scratch because we're going to use a little math helper library called NumPy. This NumPy library includes some nice to haves, outer products, dot products, multiplications, and some activations that we don't have to write ourselves, which makes it super easy. So, boy, we'll be doing that. We'll make that happen first. Hey, Blue, how's it going? Welcome on in. Welcome on into the stream. Happy Friday. You're the first here. You did it. Good job. Good job. We're going to be trying Python from scratch, mostly from scratch. I'm pretty close to. Hey, Quantify Quantum, how's it going? Welcome on in. We're going to be doing the Python deep learning from scratch. We're going to try. And we also have Copilot disabled. So Blue is dedicated. Hey, Blue, made it here first. There you go. Thank you guys. Welcome on in. We're going to be trying some, this will be really hard. This is like a hard thing because we may or may not make it. So we'll see. Shyam, how's it going? Hey, Steven, how are you? We're doing good. Happy Friday. We are going to be doing some deep learning from scratch using one. We're going to use one library, and here it is. One library. Import NumPy as NP. NumPy. NUMP. And this is just a math helper library. It helps us, and so that's what we're gonna do today. We're gonna try it. We're gonna try doing this without Copilot enabled. No AI help. Well, we might have to look up a few things just to get things going, but during the back propagation section. So we'll see if we can make it work. I don't know very well. I don't know. I think this is gonna be really challenging, but let's see if we can do it. So this is a good opportunity to encapsulate and leverage some object-oriented programming, some lightweight object-oriented programming. Typically, I'm kind of against it because what we could do instead, would it be better? Oh, hey, by the way, have you tried Python's JIT? Wait, just in time? I have not. What is Python's JIT? What is it? What is Python's JIT? I've used PyPy. I've used C Python or C Cython. I've used Cython before. But what is this? I'm not sure what you're talking about. The Python's JIT. Let me know what that is. All right. So we want to a class, a layer, and this will be let's see here. Then we have underscore init. And then I think it's self, something like that. We're gonna have some variables in there. We're definitely gonna have we have a def in it. Here we go. We're gonna figure this out. It's gonna happen. I know. Okay. Self dot input will equal numpy or np dot array dot random. I might need some help on this exact function call here. And then we need to know what size it's going to be. What's the dimensions? What are the dimensions going to be? We need to specify the dimensions. So input with 1p, and then output size. So that way we have two sizes, and we probably are going to have an activation. But we'll see how that goes. We'll probably, you know what? Yeah, we'll make that automatic. Okay. All right. So this will be input, comma, output. All right, so that'll be the initialization. Cython, or CPython, which is the default Python that comes pre-installed on your systems, is working on moving Python core into being a just-in-time compiled since it's version 3.11. Oh, is it? Okay. It is the it's in the finishing stages now. Okay. So are we going to get a faster Python? Is that where we're going to get? Python's going to get even faster, making Python faster, right? Finally, how many years has Python been around? For them, so many different side projects making Python faster. Read about that recently. This is exciting. That's actually going to be really useful because otherwise you have to use these other things like PyPy or Cython or some other runtime. And it feels better if it's if some sort of native capability, right? All right, let's do some just some readability stuff here. There we go. Did you know you could do this with Python, even though indentation was like a crazy strict thing in Python, but you could totally do this. Let's see if I can run this. It is, what is it? I think it's Python. Let me double check. It is the ML file? I think so. Yep, ml.py. Python ml.py. Is this going to build? It builds. Okay, we're good. All right. Let's get rid of that highlight. Okay, so now, hey Ashford, hey, welcome on in. We're going to be doing some hard mode stuff today. Some things that are a little bit challenging, which is going to be building a deep learning framework from scratch. What are you doing today? Oh, yeah, there we go. That's what we're doing today. We're going to try building a deep learning framework from scratch in Python. Almost from scratch. We're going to use this NumPy library here. This NumPy library. Because I don't want to have to do math. Okay, let's see here. Layer A, or how about this? We'll just do A equals layer, and then we'll just see if that works. Oh wait, it's going to require some inputs and outputs. So why don't we just say, I think we can do this, right? We can do this in Python. Python 3.14. My goodness, that's a high version there. Or we'll like to call, or as I like to call it, Python. It's the same. It's the same. You can enable it during, because of 3.14. I get it now. Quantify quantum Python. Thank you for the likes, you guys. I get the pi, but I actually like that because you can't tell if someone is calling it Python or Python because it sounds the same. Russ has changed Python world much, releasing UV MyPy. It's so fast, Stephen. It is. It is, Shyam. So much faster. Are you using OOP? I am because we're going to be using multiple of a kind of a thing. We could create another file and just call it, we can do a module, but it's going to have stateful information, right? It'll have stateful information. So we need to be, we'll just call this, WEI, weights. This is going to be the weights here. So we'll do the weights. All right, layer A. Is that going to work? Let's see if that works. We need to specify. Hey, Mom and all, welcome in. I know, Ashford, I know we're using OOP. It's something like I typically want to avoid, but guess what? There's going to be multiple of a thing. So it's going to be multiple, but we're not going to do any inheritance. There will be no inheritance. It's not necessary in this situation. So we're going to keep it simple as possible. We're going to keep it really simple. Okay. So input, we'll just do 4 and 4. So let's be 4 by 4. And then activation will be a lambda, we'll have to figure that out. We'll have to figure that out later. We'll figure that out later. OOP is good. I like organized stuff. It's pretty nice. It's organized. This is like a good use case for object-oriented programming. Here we go. All right. So we got 2 layers. Looking good. Oh wait, there's a problem. What is it doesn't want, what do you mean? Hold on a second. Non-default arguments follows yeah, we have to have a default. So we'll just say tan H. What about polymorphism? I know we're getting way too far ahead now, Ashford. No, we don't need, it's hardly ever do you need polymorphism. Like I've never, in all my years of software engineering, I've never really ever needed polymorphism for anything. I've never needed it. My live stream was a minute behind. It was quantified bottom. Whoa. We're looking good on this side. We're seeing everything. All the lights are green on our end. Maybe, but a minute behind. Wow, that's great. Hey, Apex 3744. Welcome on back in. Happy to see you here. Happy Friday. We're going to be trying to do a deep learning framework from scratch. From scratch today. We're using Python. Almost nearly from scratch. Thank you for the likes. I know it was a request. So we're going to be doing that today. We're going to try it out. So we've got a layer and then we've got a model. So we could do class model. I don't know if we have to actually, so many likes, you guys. Good afternoon. Not Owen, welcome on in. Good afternoon, everyone. Thank you for all the likes. Appreciate it. Lots of likes there. Christopher. Hey, Christopher, assign manual algos to activation function. Yeah, that's what we're going to do. Where can I learn from basics? That's what we're doing right now, actually. We're learning the basic here. How are you so upbeat all the time? Eating good food, healthy food, right? You want to eat vegetables and eat more vegetables. Fruit is also good. Beans and seeds and berries. You guys got to eat all those things. There's no need. You don't need coffee anymore. If you eat properly, you don't need to eat coffee. It's crazy. Const SMS notifications enabled. User.preferences ? Notifications ? SMS. What? Console log SMS notification enabled. Output. What's going? Someone redacted. All right, Sin. Hey, how's it going, Sin? What's your take on someone who wants to start learning machine learning and deep learning? Here's a good way. So we're going to actually do that. So we'll try the best we can to do some. So here we go. We're doing it right now. We're making it happen. Let's get rid of the activation for now because we're not using it. But we will add it later. Let's see if that's still looking good here. Thank you for the likes, you guys. Random. Oh, see now we got to, so is it, maybe it's just numpy.random like this? Maybe it's just numpy.random. Yeah, so many likes there. Appreciate it. Is that going to work? Because still no, oh, wait, module object. Wait, hold on. What do you mean? Module object is not callable. Oh, wait. Yeah, it is. Hold on. All right. So, I need to figure out, so I'm going to enable Copilot really quick just to figure out what the syntax is. Hey, Espanol, welcome on in. Welcome on in. We're going to be doing some deep learning today. Copilot enable, just real quick. And we'll say, numpy random. Wait, yeah. NumPy. Oh, so we have to do it like this? Is that what we have to do? Okay, fine. There we go. There we go. All right, we'll do it like that. Is it happy now? Is it happy? Let's see if it's happy now. Let's see. Copilot disable. We're going to try it without the AI as much as possible, but maybe for like easy stuff like looking up docs. All right, there we go. So we got that. We're good to go now. We're good to go. Let's see if we can print it. Print a.w weights. Weights. Yeah, there we go. Let's see if that works. Are we going to print? Are we going to get data? We're going to get data. Okay, there we go. Now we've got the brain, you guys. We've got the brain. Yep, I missed the .rand. That's what I did. Random.rand. You got it, Christopher. You got it. You guys are knowing. For now, let's hard code the activation function and see some outputs. Yes, that's a good idea. So we'll hard code it. I like tan H is one of my favorite. My tan H. Tan H is one of my favorite activations because it just does a really good job. It does a really good. It's not the cheapest one. It's not the most efficient one, but I really like Tan H. It's really my favorite one. What's your thoughts on lead tech on YouTube? He bashes coders and coding. He thinks it's a waste of time. What is walking outside a waste of time? Yeah. Is playing video games? Is reading a book? Like, I mean, a lot of these tasks are fun and entertaining and you just want to do them. But also I think coding is necessary. You need to sort of have an inherent understanding of, from an engineering perspective, how to interpret what the code is going to be doing. And the best way to do that is to actually write it yourself. I think that's one of the best practices. Write the code yourself with your keyboard, right with the keyboard, you guys. Programming. Hey, how's it going? Welcome on in. So I would say it is not a waste of time. It's actually valuable. And what are we all here for? I don't know. We're just hanging out. So might as well do something. We might as well do something. Okay. So we've got some layers. We got some weights. And then we need a forward function. We need a forward. So def forward. That will be self. There we go. And then we need a loop. We need a loop through it, you guys. Oh, actually, forward. We need the inputs. Inputs. There we go. We need the inputs. Best activation function is heavily dependent on task objective. You're totally right. You're totally right. It is. There are some, like the output activation is typically depending on what your output's going to be. What do you want to target, right? Usually it's going to be a 1 or a 0 for classification of some sort, which is what we're going to be doing today. We're going to try to do, maybe we'll do an XOR. Actually, you know what? I don't know if we'll make it. You guys. This is a task on its own here. Hi, Steven. I'm conflicted. Should deep dive machine learning or language design, programming languages? I would say it's probably quantified quantum is probably better to get machine learning going. It's probably because that's the future that we're in right now. Language design isn't so beneficial because there's a lot of languages already out there and there's a lot of tools. But you know what? Language design will help you understand more of what you're building with other coding languages. So maybe a smidge of that, maybe just a smidgen. But if you want AI and machine learning, it's far more valuable. There you go, far more valuable. Very valuable to learn how to build neural networks by hand. It is, and that's what we're going to try to do right now. We're going to do it right now, but we're going to do it from memory. Chat, you can help as much as you want. You can help chat as much as you want. We're going to try the best we can. We're going to try the best we can to get it to work. Okay, so so we get inputs, and I think we can do an @ sign, and then the self.weights. I think that return. Let's see if that works. Let's see, but we didn't activate it. That's not, so this is output, or we'll just say out equals. And we'll copy this over here. There we go. Comma, bird. Let's go over here. And then we want the activation, right? We don't know what the activation is going to be yet. Some functions I know. Input equals hidden rel u sigmoid tan h output softmax. Yeah, softmax is good if you have if you're doing a classification, right? But if you're doing a binary classification, you obviously only need one output, or if you're trying to target between two different outputs, then yeah, softmax would work pretty good too. Depending. So when you're training though, you want to target one specific output depending, I guess if you have multiple assignments, like if you have, what is that called? When you're trying to assign some like attributes, right? You want the AI to detect attributes of whatever the input is. Then you're going to have multiple outputs that can all be on at the same time. And so softmax may or may not work well in that scenario because you're polluting some. Yeah, it depends. It all depends, right? Let me see if I can get missing some of the chats. Can you make a compute layer? JB, what do you mean? Can you make a compute layer? What do you mean? Let me see. Coding is boring because I feel it has no meaning in my life. Espanol, really? Oh, it's so good because you struggle. Like here, we're struggling right now. And if we get it to work, it's like a reward. It's like a brain magic reward. It's like amazing. It's like whoa, it worked. This is a happy feeling, when you make it work. Me making a neural network by hand. All right, time to make a transistor. I know there's so many frameworks out there. You don't need to do this, but I think it's really helpful to understand how it kind of works behind the scenes. So that way you're happy. I do think we do need an activation. Activation is going to be no, not there. Where's the activation? Self dot activation is going to equal. Does NumPy include 10H? What is it? Actually, we should have activation here. What is NumPy's? I'm going to enable Copilot really quick. After dozens of hours done, a few billion more to go. I pretty much apply a complex calculation in the layer. Oh, JB. Oh, I gotcha. Okay, so we could add like a lambda of some sort. We could add a lambda or a layer that has a very specific kind of computation that does something with the weights, like a dropout or something we could do with some randomization in there, things like that. But I think that makes sense. My humble obstinance sensei. Consonance sensei are we doing today? Okay. We are doing, Manu. Hey, welcome in, Manu. Okay. Activation has to be written by hand. Okay. Maybe. No. The formula has to be expressed manually. Well, it can be. So if we want to do sigmoid, so I'm not going to fully remember what the activation is for, because we also need the derivative as well when we're doing back propagation. And even if we get that far, we're going to try, you guys. We're going to try. So what we're doing today, Manu, is we're trying to write here. Today, we are writing AI or I guess ML framework from scratch or from scratch-ish, right? Because we're using NumPy. Because it's otherwise, thank you for the likes. Otherwise, you guys, I would have to write a whole bunch of for loops and the code would get really busy on screen. And we don't need to write some for loops just to, loop through all the arrays on the screen. So you can see here on the other side of the screen, we've got some arrays over here. You can see what the arrays look like. So that's what we're going to do. Today, we're writing an ML framework from scratch. I recently saw someone build ChatGPT in Minecraft from pure redstone logic. I was on the internet as well. I did run into a video where, what would they do previously? They made Minecraft in Minecraft, right? With redstone, and they had a screen and everything so they could play Minecraft in Minecraft, but that wasn't good enough. No, it wasn't. It wasn't good enough. They needed to build ChatGPT in Minecraft, which is way overkill. They probably needed a huge, like a terabyte of RAM or something. I don't know how they could have possibly achieved that, but it would have been amazing. Yeah, we got to need a supercomputer just to handle all that redstone overhead. You're totally right, Quantified Quantum. You're totally right. All right. I do need to, I don't want to, let's see here. So how do we do tan H? So I just need to enable Copilot really quick. Copilot, just for some document. I know we're doing this from scratch, but I mean, just a few things makes, because otherwise I have to go to Google and Google it, and I don't want to enable. Here we go. We need tan H activation. All right. Let's see here. Okay, it is numpy.tanh. Okay, so that's all we have to do. This is all we have to do. Boom, boom, boom. There we go. Right there, like that. So we're doing a little bit of helps there. Hey, Sachin, how's it going? Got your great stuff. There we go. There we go, you guys. All right, machine learning from scratch. We're doing machine learning from scratch. All right, so we have our activation function. And then we can put a comma there because we like trailing commas. You don't need it. You don't need it, but you kind of like it. You kind of like it. Okay. And then self.activation will be the activation. There we go. And then we can just do this. Return. Wait, I got to disable Copilot. Copilot is getting on disable. Here we go. Disabling Copilot. I vibe code on my front ends. Yeah, I mean, that's what we're doing today. Or that's what we all, today as in this day and age, where we are software engineers going forward. We don't write code so much, but we use the AIs to do that for us. Basically, that's the new way of things. That's the new way. Daniel, how's it going? Welcome on in, Daniel. Espanol, could you make a project with functions? What do you, that's what we're doing right now. We've got some functions right here. We've got our init function right here. And then we've got a forward function. So let's do return self.activation out. There we go. There we go. So now we've got our forward, right? We've got our forward, but I do want to say self.output equals out. Here we go. Because we need to save this. We need to save the output for training purposes. When we're training the model, we want to save the output. I know, I remember this. I remember this part. You should definitely use LLMs for syntax and stuff or we won't be able to finish this in time. I know we're going to have to use a little bit of documentation help because are we going to finish it in time? I don't know. We could barely finish a linked list previously. We could barely finish yesterday's linked list, but I did. I went back here. We'll take a little break real quick. Oh, wait, let's go back here. Let's do here. So I did. So here's our linked list from yesterday. I did just do a real quick on it. Instead of saying tail, I like next on the node itself. And then you can append the head and tail, and then, I changed a few things around. So you can append, and then I did a map. So you can loop through all of the linked lists. And that's all we did. That's what we did yesterday. We barely finished it. But I went back. I really wanted to, just for fun, I wrote this map function. And then you can specify your own function there, and it looks like this. So you just say node list.map. There you go. AI is boring. Espanol, what do you meaning AI is boring? It's exciting. It's the biggest. It's overhyped, maybe. You could probably say it's overhyped, but I think it's actually really valuable. I think it's really valuable. Final project of assembly series, making a super simple model in ASM, quantified quantum. I really want to do that. I think that would be a lot of fun. All we have to do is figure out how to do some of these array operations, matrix multiplications. We'll make our own file that does our own function that iterates over a whole bunch of matrices, and then it multiplies and we get the output. And then we do a super simple one, We'll try it. We'll do a super simple one. Okay. So we've got a couple of layers. Does the @.do.product? Yes. This is .product, and it's supposed to be outer product. We want to do outer product or .product, but I think we want outer product. But we'll see. We'll see how it works, you guys. We'll see. Inputs. Okay. How do we do this? How do we make it work? I got to remember. If the code works, then no. If not, yes. That's basically. AI is effective and efficient. It is. It has its uses and purposes. AI is underhyped. It actually, Christopher, you're right. There are current capabilities today that AI is not being exploited for. And we have to automate everything now. We've got the whole world at our fingertips. We can automate everything. The whole world can get automated. Do you do Android development? A little bit of Kotlin. Light. Good name, Light. Yagami. Light Yagami, how's it going? Do you do Android development? Maybe a little bit of Kotlin with Android Studio, things like that. 100% Christopher. Nice. All right, here we go. All right, let's see if we get our code to run here. Is it going to run? Okay, so we've still got it running. It looks good. Okay, so we got our forward, and then let's try to do a forward. Let's do input. Let's do XOR. Let's do XOR. I think that's easier. Okay, let's do input data, or just say data. Here we go. Data will be numpy or np.array, and then we'll specify this from scratch here. What will this look like? You can also do dot using dot. Oh, with the dot np.dot. Okay, cool. Thank you. We might need to do that. It depends. I need to see what the output looks like when we do this. Here we go. So, blur, 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 like this, comma, this, and then I think that's, so we're going to have, we need 4. I think we need 4 here. 1, 2, 1, 2. Is that right? Is that, my brain can't see it. Where is it? Oh, because there we go. And then we go here. We're creating a data set. We're creating a data set. This is, I would call this X. We'll call this X and Y. Which basically just means input and expected outputs. That's all it is. So this is training input data, or the features, right? Or here, features, or input, or it's called training. This is the training. It's like the input data, and then we've got our labels here, which is the output data. It's the expected output. Expected output, right? Result. Answer. It's the answer. There we go. I like that better. How much do you use AI for coding, Sagar? I use it all the time, but guess what? Right now, I'm disabling it because we're doing hard mode. I think it's a lot more fun. It's like in video games, there's like a difficulty setting. We put it all the way to the most difficult. Nearly to the most all the way difficult. We can go super difficult, like quantified. Quantum was saying earlier, like we can build an AI deep learning framework in assembly language without any AI help. We could totally do that, but that's a little crazy. So the only thing I'm using is NumPy, which is going to help us with some basic math, some math that we don't need to repeat. It's because it's foundational math and it's not anything crazy. Okay, let's see here. What file, wait, hold on, Espanol. What this file of coding means, you have made for. This is, we're gonna create, so I'll show you here. Is this right? No, I need that there. Okay, so we have 0, 0, 0, 1, and then we have 1, 0, and then 1, 1. All right, so we're gonna do an XOR. We're gonna do an XOR is what we're gonna do. Okay, and so the answer is, and we go over here, copy paste that, and make this a Y. And the output only needs to be, we only need 1 on the output. So we'll kind of do it like this here. I've got an idea. There we go, like that. Something like that. And we can go bam, bow, and bow. There we go. And so what the answer is, in XOR, both the values need to be the same. So this is 1 here. And then this will be 0, 0, and 1. So I think that's what XOR is, right? I can't, oh, wait, someone's got, wait, 0, 0 equals 0. Oh, it's the opposite. 0, 1 equals 1. Okay, let's switch it up. Boo, up, and then down. Thank you. Wait, down. Down. There we go. Thank you, Blue. Thank you. Are you a CS graduate? Like, I thank you for the likes. I dropped out. I dropped out of college. I dropped out, you guys. So there you go from that. Do you know Honor of Kings game, HOK? Honor of Kings, actually, I don't know. I don't know about Honor of Kings. I've not played it. Tell us about it. Oh, hello, Steven. This is my first time here, being here. I do have a question for you. So, I am biologist. You're a biologist? That's great. Do I want to go into bioinformatics? What programming languages do you suggest? Python. I suggest Python. We're doing Python right now. I recommend Python because it's part of all data science, all part of AI and machine learning. Python is the premier go-to language for this. It's simple. It's easy. It is easy to understand. There you go. Python is the answer. Here we go. Let's do this. All right. So we'll do SURYANSH. Use Python for bioinformatics. bioinformatics. Use Python for bioinformatics. There you go. Python for bioinformatics and other kinds like and analytics, and AI. There you go. There you go. Python's the answer. I highly recommend it. Okay, sorry. Hey, I started with C++. Hey, me too. You and I are the same light. We both started with C++. It was a mistake to start. But back in the day, C++ was the only thing that really was accessible. There were that I knew about. So I didn't know what makes sense if you're trying to get into computer programming. What language? You just start wherever you think you ever know to start. Python is king when it comes to AI. You're totally right, Christopher. So many libraries and active communities. You got it. Okay. Python is the answer. Okay, so let's see here. So we've got our X and we've got our Y. So we should be able to do a forward. We're forward with our A. Let's see if we can do forward with A. Also, we don't have any. We don't have a bias, and I don't know if we'll have time to do a bias, but I think we can do it like that. Let's just put this over here like this. We probably won't use it, but we'll have it ready. We'll have it ready to go. We'll have a bias. Boom, bias. There you go. What IDE are you using currently? This IDE right here, what we've got going on is called a tmux, but the IDE itself, the actual text editor, is Vim. VI, you guys. It's called VI. VI. It's my favorite text editor. Do you think Rust will be the next Python? I think Python. What needs to happen in order for that to occur, Sachin, is we need a Rust simple mode. We need a simple mode in Rust. Right now, Rust is not simple. It's got a whole bunch of abstractions and difficulties to understand with lifetimes and the borrow checker. And there's just a lot of difficulties when it comes to using the language. It has a high learning curve. And if it had a simpler syntax like Python, then Rust would be, I would say. But in terms of they're different tools, right? They're different tools. So you could use Rust to build fast, highly performant code that is for mission critical situations. For learning to code, though, it's not a good choice. You don't want to. Vim mentioned. You got it. We need to always have a Vim in there somewhere. We need a Vim. Here we go. Vim. Here we go. Vim. A whole bunch of Vims. Here we go. Vim mentioned. So many Vims. Though starting with an object-oriented programming language, OOP has its own set of problems and benefits. Light, you're totally right. You got to keep things simple. You got to keep things simple when possible. For the basics. Okay. We've got our inputs. Let's see if we can do all right, so we've got our weights there. What if we do, let's do out. Out equals a dot forward. Let's see, then we've got X, and then let's just print out. Here we go. All right, let's see where we get to. Is it going to work? I think it's going to work. Oh, no, just kidding. Just kidding. All right, we got to figure out what's wrong. Weights, W-E-I-G-A. Oh, we spelled weights wrong. That's what we did. Because we're not using, here we go. W, weights. There we go. Is that right? Yep, looks good. All right, let's try it again. Oh, just kidding. There's something else wrong. This is the thing, you guys. This is the thing. Hey, mate, prompt fail. How's it going? Well, come on in. Making your own layer is most useful for applying calculations specifically for your tasks and data. To be honest, I'd say if one does manual memory management in C and C++, one realizes the pros of Rust. You got it. Rust helps a lot from that perspective. Rust is like a layer above from. It's a step up from C, but it has the C performance. And you get all these concurrency and memory safeties with Rust, which is so cool. Thank you for the likes, you guys. When I see multi-functions, I am confused. I cannot understand. Multi-functions? What do you mean multi-functions? There's only there's two methods here. We've got an initialization method and a forward method. All right, so out equals inputs dot weights. Oh, wait, no, inputs is the right dimension. Are we talking about matmulp input op1 has a mismatch in its core dimensions. Okay, so our weights, let's see, x, let's print out, let's do this, print x, and then print a dot weights. Let's see what that goes. Let's see, and we'll highlight that. Close that off. Okay. Might have a transpose matrix. It is. I think that's what we've got to check out. Okay. Because of 4 and 4. Okay. So we've got a 2 by 4. So we need the input layer to match. So input equals 2, output equals 4. I think it's that. I think we have to do that. You guys. I think we have to do that. But first, layer object has attribute weights. Has no attribute. WEIGO /WEIGT. Where's that? Oh, all right. W. There we go. I got to spell things correctly, you guys. Got to spell things correctly. All right. Oh, wait. Hey, a little tip. IDK, if I should, YouTube, but do something like 30-minute focus and 5-minute chit-chat. Okay, that sounds good. That sounds good to me. However you want to do it. Hey, Deja Woo. How's it going, Deja Woo? I'm so happy this showed up on my feed. I have to learn now to rig in Maya. Oh, Maya, the 3D studio. That's a big program to learn. Are you talking about Maya, the 3D rendering engine thingamajig? It's a really powerful app, isn't it? But there's a lot to learn in Maya. It's a whole industry all on its own. But happy you're in here. We're going to be doing some AI here. We're doing some AI. Let's see if it fixed it. Okay, we fixed it. All right. We fixed it. See, these like little wins, you guys. Like when you have something, you have it, you try it and it doesn't work. And you're like, why doesn't it work? What's going on? I don't understand. It's not working. And then you fix it. It's like a really happy, satisfying feeling. So this is the fun part. The fun part that I have forgot all about because I've been using AI for so long. Hey, yeah, Deja Woo. Yeah, prompt fail. There you go, Deja Woo. All right, here we go. All right, so we fixed it because of input output, and we have layer. We'll do this. We'll just copy and paste so we know, so we can see it. We could also create a model, and then so layer B, and then let's do C, and the C will be output. And we'll do 1. Here we go. All right, so this is our model. Here. But we also need to specify a output. What should it be? It should be sigmoid. I think it looks like your live CC is a bit inaccurate. Yes, it is. Because it only knows so many words. It only knows a few words, and it has some inaccuracies, especially if I speak too quickly, then it will have a challenge keeping up with me. There we go. Yeah. So I have to focus on that. Otherwise it does struggle sometimes to keep up, but if I speak clearly and I speak slowly, but sometimes I get too excited. And so I have to speak a little bit more quickly. Okay, here we go. So we've got our feed forward, and let's see if we can actually get it to feed forward now. Let's try it. Let's try to do feed forward. Is it going to work? It feed forward. Look at that. But hold on. I see a problem. Oh, no, we got zeros, a whole bunch of zeros. Okay, that's actually fine. Because that's expected because we're multiplying these zeros with the initial zeros. So here, check it out. All right, so this works. We did it correctly, you guys. Our outer product is working correctly. And it has an activation, and it's working. We did it, you guys. This is so cool. Okay. Now that we did that, what's next? What do we do next? Okay, so we have to propagate that data forward. We have to propagate the data forward with each of these layers. Let's at least try to do that. So, out. We'll just do a out. We go let's do A out like that. I think it's good. You could use the new Gemini Live sub 600 millisecond accuracy. Really? Thank you for the likes, you guys. We'll have to check that out. We'll have to look at the new Gemini Live. We'll have to check it out. I think that would be fun. All right, that'll be a task for later. Okay, so we got A out. Here we go, and then we'll go here. And then we need to B and C. C it out, but we do that with B and C. There we go. And then not X, but A underscore out like that. And then B underscore out. Thank you for the likes, you guys. I can see the heart icons showing up there. Here we go. And so we should be able to print C out, which should be a simple, well, it should be an array of 4, right? It should be an array of 4. for closed captioning. Yep, you got it. CC, there you go. CC for closed captioning. All right. So we've completed. Are we almost? So basically, check this out, you guys. This is the very front end. Thank you for the likes. The front end of an AI, what it looks like, and especially in a deep learning AI. Well, I guess it's nearly deep because we got 3 layers. So I think that's pretty deep, don't you? I mean, we could go more, but I think 3 is enough for now. 3 is enough. And so you can see here, expected input size is 2. And then the output size is 4. So we've got 4 dimensions. And you can see that's because we're expecting 2 variables to be the input. But our batch size, here, let me pipe this over here so we can see better. Our batch size is 4. So you can see we've got an array of element of 4, right? So you got 4 elements in there. That's a batch size of 4. And each of these elements in that array is 1 training sample, essentially, or 1 input at that point. So what we've done is we feed forwarded a batch size of 4, and we got the output here on the screen so you can see what the results are. Now, it's random data. It's random. And so what we have to do next is train the model. And that's the hard part. That's the hard part, you guys. So we're going to need to implement some mean squared error. We'll have to do stochastic gradient descent to do the training. And we'll have to create a loop for that. And then we have to do back propagation. And then we have to optimize. So I don't know if we're going to finish. That's like we did the easy part. We did the feed forward part. Are we going to be? I don't think. I have an expectation that we won't get that far, but we will try our best. We'll try our best. We'll see we'll see how we're doing. I mean, we're already 40 minutes into the stream, and I do have a meeting coming up in a bit. Not too soon, but we've got some time. We've got a little bit of time, you guys. All right, let's try this out. All right, so now that we've got the output, what we can do is we need to put this into like what do you call it? Let's see here. Print that out. This needs to go like in a for loop for training purposes. So this is that. We do need a backward propagation. So this is the tricky part. Def backward, and we have self, and then we have I guess the output or I guess the previous value. I don't know what to call this. I don't even know what to call this data. We'll just use data. There we go. Data. That's what we'll be generic. We do need a better name than data, you guys. We need a better name than data. All right. So what is it going to be? So in order to back propagate, we have to do. It's basically the opposite, right? It's the opposite, but we need the derivative. We need the derivative activation. What is the derivative of tan h? Oh, but we're also using tan h on the output. On this final output, which we probably don't want. We probably want to say activation equals maybe like a round. Can we do round? Is rounding good? Is that a okay activation? Can we just use rounding? Like math.round? Round? Can we do that? Is that a thing you can do in Python? Is that a thing you can do in Python? Math.round. Wait, I'm thinking of like JavaScript, obviously. 0.5. All right. Math. Oh, do we have to import math? Right. Import math. I actually don't know. Import math. It's been so long. But there's probably enough. Oh, you do have to import math.round. 0.5. Is that it? Math has no attribute round. Great. All right. Great. We'll figure this out, you guys. We'll figure it out. Isn't it a lengthy process writing and building logic on my own? It is. It is. Yeah. When AI write all your code and you just update accordingly. Yes, you're right. We're doing some hard mode challenges here. Can you use a CSV file as training data set in NumPy arrays? You're totally right. You can. You can't. All you have to do is import the data, and you just want to make it match it however you want. Match it however you want. So like this is essentially our spreadsheet right here. If you can see on the screen, this part, this is our spreadsheet data. But then we've separated it into input and output data. So we've got our input data, which is 2 variables, right? You got 2 datas, 2 variables to your input, and this is a batch size of 4. So it's essentially 4 rows. Yeah, 4 rows and 2 columns. It's a 4-row, 2-column array right here. And that is basically our spreadsheet. But then you also have your answers, which is right here. So this is your output data, which is what the data is we're going to train on. This is the target data. This is the target. What you call the target, the expected output. So you're right. I don't know much. My question could be completely senseless. No, it's totally right. You've got to spot on. So when you're in the real world and you're building real AI applications, you want to use a spreadsheet or some other kind of data file format. And any comma separated values is totally fine. Comma separated values is totally fine, you guys. Yes, you can use pandas to create a data frame. Ah, yeah. Open CSV. There you go. Comma separated value file. You got it. Sir, are you a senior developer or are you just researching and learning? We're always researching and learning. We're always researching and learning all the things at all the times, you guys, and then convert it to a NumPy array. Yes, you got it. So that's one of the challenges with AI. One of the most difficult things that's kind of hard to forget or hard to remember is that your input data and your output always needs to be between between -1 and +1. I mean, you can there's some room. You can go a little bit further. It's probably fine. You can go like -2. Wait, hold on. Let me undo X. You could probably do something like this, and go like between -3 and +3. But it's best to keep it to 1. And learning never stops. You got it, Christopher. Learning never stops. Also, forgetting never stops. And so it's nice to refresh every once in a while. And so that's what we're doing today. We're refreshing. We are refreshing, you guys. So we've got our comma separated data here. Oops. And we've did a feed forward. So we have that, and we've got our output data. Is that doing correct? So we've got math.round. I think we can do import. Let's do import math. But math.round isn't. Thank you for the likes, you guys. Stream agenda or chill vibe. Rot. Oh, whoa. Thank you for the donation. Well, check that out. Whoa, check it out. Thank you so much. Both chill vibes and stream agenda. We're building a deep learning framework from scratch. It's sort of from scratch. Thank you so much for the donation. This is awesome. Here, I'll click the like button, and then we have to respond to that. How do we respond to that? Can we respond to it? I don't know, but what we can do is we can say at UJJ. There we go. Thank you! Explanation point. And then we'll do a Python, and then we'll do a wave symbol, and then we'll do a happy symbol. Okay, here we go. Thank you so much for the donation. That's really fantastic. I appreciate it. That's amazing. Thank you for all the likes, you guys. Yeah, we're doing some AI today. We're learning AI from scratch. So we started with an empty file. We turned Copilot and all the AIs are turned off. And so this is a hard mode now. I mean, up to a point, we'll still use a few things. We still need to look up some things every now and then, but it's turned off. The AI is turned off, and we're trying our best. We're working from memory. Thank you for the likes. Appreciate it. Thank you again for the donation. That was wonderful. Wujawal, Keshri. I don't know if I say your name correctly, but thank you. That was really awesome. Appreciate it. It goes to say it's very heartwarming and a very positive feedback. Thank you. I appreciate it so much. That is wonderful. Okay, here we go. Check this out. All right, so we've done our feed forward, but now we are going to have to do. So let's see. Let's specify some epochs. Let's do like 100 epochs. No, yeah, 100 epochs is good. Let's try that. So we'll do a for loop. How do we do for I in range? Do X range? Oh, range. I'm thinking Python too. We'll go epoch. Let's try that. There we go. So print. We'll go f epoch, and then we'll go I like that. Epoch I. Okay, there we go. And then we do this, and now we've got our training segment. Training. There we go. Train. First, let's put the epochs over here to a smaller number because we're not ready to train yet, you guys. Can you create a voice clone app from Python? Yeah, you can. You totally can. There's a really good model that just came out, and it's like the best voice cloner model that you can use in Python. It was really good. I tried it, and it was like nearly perfect. It was nearly perfect, you guys. Don't worry, I'm an Indian. You wouldn't be able to easily pronounce my name? Oh, yeah, I figured as much. What are you building, sir? We are building an AI or a deep learning from scratch. So we're doing, today, we are writing ML framework from scratch for the most part. We're importing a couple of libraries. So should the for loop be in a fit function? That's basically what this is. This is the training. This is the fit. Or like a dot train or a dot fit, right? Because you've got these different methods that are like that. That's basically what that is. So we're going to try to do that. We're not there yet. We don't have it fully yet. But you're totally right. Hey MD, how's it going? How's it going? We're doing the AI. We're trying. But we need a backward. Let's see. Pass. Here we go. Let's see. We do need to do back propagation, which I forgot how to do, actually. I forgot how to do this part. I know. And then we need an optimize. I know we need an optimize. So let's see here. Copy, paste. Let's go like this. And then optimize. Wait. We don't need to do that. I guess we could, but we don't need it to be, the optimization function could be outside of the layer. Outside of the layer, you guys, because we optimize each of them. And then we need to do it backward here. So basically we need to do the opposite. How do we do backward? Oh, because we have the output. Oh, got it. Okay, so we have the output, self.output. Okay. We're going to figure this out. Hey, why are we changing the activation of the last layer? We have to. We need to change the activation. Well, do we need to? Do we need to really? I mean, it's better because the tanh has -1 and a +1. But our training data is saying that it's going to be 0 and 1. So we want something that's going to activate within that range. So tanh will activate between, so tanh equals basically -1 to +1, right? So that's tanh. But we need something that activates like sigmoid between 0 to 1, something like that. So that's why we need to change that. Because it's like that. We don't have to. So you know what? You're right. Let's keep things simple for now. And not. Although I really do want math. So how do you do round? How do you do rounding in NumPy? Is there a NumPy? But here's what we're gonna do. Can you use NumPy's array and pandas data frame together? You can, but NumPy has its own math, and so you have to convert data frames into a NumPy array before you can use the NumPy features. What is craziest thing you built from Python? That's a really good question. What is the craziest thing in Python? The thing I can think of are some like high scale services that we had in our infrastructure. I don't know if you can consider it crazy, but we did write some Python that we've since replaced with Rust that did a lot of things in our infrastructure. Like tracking connectivity of devices and then storing messages into a database. That doesn't sound like it's complex or crazy in any way, but when it's over 3 trillion messages per month, it tends to be a thing that needs to be paid close attention to. So that's the craziness. What are we doing? Danik, hey, how's it going, Danik? Today we're writing machine learning from scratch is what we're doing. ML from scratch. That's what we're doing. We're going to try the best we can. We're going to see if we can make it work. We have to pull it from memory the best we can. But let's see here. We'll keep things simple for now. We won't change that. We don't need math anymore. There we go. Sigmoid is typically the last function for binary classification tasks. Exactly, and that's what we need. That's what we're doing right now. If or round, float, place, int, if not mistaken. Yeah, so that is absolutely yes. Yes, we could also do that as well. We could absolutely also do that for the output layer. But for now, we'll just keep it simple. We'll just keep everything tanh, and then we need the derivative of tanh, right? So what is the derivative activation derivative, which is basically the opposite. NP dot, was it is it tan HD? Is it tan HD? No. Or is it P? What is it? What is it? Import numpy. Let's see if we can do np.tanh is, right, as np. And then np.tanh, right, is a function. What about D? Nope, that's not a function. What about, is it D? Oh, it is. It's D. Wait, is it? No, hold on. No, not D. What is it in NumPy? Is it 10H? What's the... Okay, we're going to have to Google this. We're going to have to Google this, you guys. Let's see. NumPy tan H derivative. How do we do that? How do we do that? We need a little bit of documentation here. Tan H derivative? Oh, we have to write it ourselves? All right, that's no problem. No problem. We'll write it ourselves. We'll write it ourselves. No big deal, you guys. No big deal. All right, tan H derivative. Boom. We got it. We got it. All right, so we'll do this. Here we go. Over here. And then that will be lambda x colon paste. There we go. Like that. Just like that. Isn't that cool? Now we don't have to worry about our activation or our derivatives anymore. We don't have to worry about that, do we? We don't. Nope. Not a little bit. Not at all. Okay, so we've got our output, and then we've got our data, whatever that's going to be. I know we do need to go backward, and I forgot how to do that. I forgot how to do the backward part. How do we do this? This is the part that I always forget. How do we do the back propagation? I get the optimization because we just do some learning, but how do we do this, you guys? I forgot. I know it's data at, but we also have to use the derivative. So self dot derivative here. Oh, but we can't directly. Here's the deal. Because we're doing it like this, it's an array. So it's expecting the x is a single number, but we have to loop over it. X. So we could do something like map x, and then we say lambda n, maybe we can do like that. Map x. Yeah, map x. So this is the input data here. And then let's see if we can get. Let's write this in a function. Let's make it a little bit easier. Let's make this a little bit easier for us. Here we go. So def tan hd. This is an array. We'll just an array like that, right? We're figuring things out. And we go like this. We need the map over in. We'll say in here. And then what else? Is it? We don't need that anymore. We need this. So this is actually the tan HD. This is the actual tan HD algorithm, like that. All right, we're gonna figure this out. I promise. We'll figure it out. We'll at least get close trying, you guys. We'll get close. All right, so we've got 10H, and then wait, is that actually how it goes? Is it actually like this? So is that the actual derivative? Because we don't want to re-tan H something that's already been tan H'd, right? Is that right? We don't want to re-tan H something that's already been tan H'd. Is that actually the answer? Is that really the answer? Efficient? I feel like we're missing something. Oh, hey, I'm writing a bash script for FreeBSD that works like free command to Linux to show memory and swap usage. Oh, that's kind of cool. So you can see how much RAM and swap is being currently used on the operating system. That's actually a really cool script. You could just use the free command, but that only gives you memory, right? So free. Oh, wait. I'm not on Linux. I'm not running Linux. So I don't have the free command. But yeah, that actually sounds really cool, MD. That sounds amazing. Let's see here. So I am struggling. I feel this is weird. I feel this part is weird. Are we sure? So I know we have tan H here. But what about the derivative? I feel like oh wait, arc. Oh, is it called arctangent? Can we do arc? Is arctangent the same as derivative? Same as tan H derivative. Is it the same, or are they different things? Oh, whoa, hold on. Not interested? right now. Thank you, Google. No, the derivative of arctan is not the same as the derivative of tan h. The derivative of arctan is this, and the derivative of tan h is SECH2. Okay. Can we do the derivative of tan h looks like this? Okay. Can we write that in Python really quick for us? I need that help. I need help. Hey, MD, how's it going? Quantified Quantum says, write tan h derivative in Python for me. I need help. I need help with this because I don't remember it keeps saying that this is the derivative, but is it? I guess we'll just have to try it out. Here, we can test it. You guys. I didn't even think of this. Check this out. We can test it. Okay. So we've got NumPy, right? NP. We've got NP. Yep. We do have NP, right? Yep. Looking good. Okay. So we can say np.tanh. We say 0.5. Let's do 0.4. And it's going to be that number there. And then, well, let's see if we can. Let's see. Is there a bigger? Can we do? Let's do 10. Okay. Let me just do 4, or maybe 2. 1. Okay, we'll do 1. And then if we do the inverse, right? If we do a derivative, it should be nearly the opposite, right? So we can do this, like that. But wait, a equals np.tan h1. So you got a, and then can we do the opposite? Which is going to be this. Let me say a like that. No, not z, a. And then it returns. Is that the derivative? Or because it seems like it seems weird. It seems weird to me. It just seems odd. Is that actually what the derivative is? I don't know, you guys. Free is not available on FreeBSD. Oh, there you go. It's also not available on Mac OS either. Hello, sir. How's it going? It says MD to Quantified Quantum. All right. We're struggling. We're trying to make this work. We'll see if we can. So on one of the most simplest things. Okay, so we have this. Like that. And then so we need to take loop. Oh, we need to loop over it. 1, 2, 3, 1, 2, 3, 4, like that. Tan h derivative. We'll try that. So this is the derivative. And then we need to map on n lambda. We'll call it lambda x like this. Maybe like this. Something like that. Maybe. I don't know. There we go. Going good. Good to hear. All right. Let's see here. So we've got map. Let's say out equals. So basically this is an array. But it should be an array of arrays, right? An array of arrays, but NP. But maybe, hold on, because we're using NP, we don't need to do all these fancy things, right? Because we're using NP, we don't need to do these fancy things. Is that right? So hold on. Let's see if we can get this. All right, so NP, what if we do, right? So let's do np.tanh on a array. I don't know if we can do this. So we'll say 1, 1 like that. Let's see if that works. Is that going to work? Oh, I didn't finish typing. Where is there missing? Oh, here we go. Wait, np.tanh. No, wait. Oh, okay. That way? I don't know. Oh, okay, but it gives me the data that I'm looking for. Okay, so I'm overcomplicating it, you guys. I'm overcomplicating it. So we really only need this. Okay, here we go. Let's bring that back. Derivative there. Okay. All right. So now that we have that, we can do back equals this, and then we could choose to optimize at this point, which maybe we should optimize it. Let's see, learning rate, learn rate equals 0.01, a low learning rate. See ya, everyone. All right. I'm over my screen time limit by about 4 minutes. Got to go. Cool. Have fun. Have a good weekend. We'll see you next week. Manish, not understanding a single line. Hey, don't worry. I'm struggling as well. Hey, how's it going? Fazan. Hey, Zaya. Fazan, how's it going? Welcome on in. We're trying to write a machine. It's been a couple of years since I've done this. A simple machine learning framework from scratch. We got part of the way there, and we will have to get going here pretty soon, but not yet. We still have some time left. You guys. We just implemented the backward propagation section. Thanks, Steven. See you next time. See you next week. Cool, Joe. Thank you, Joe. We'll see you next week. Happy to have you in here. We're gonna see if we make it. We'll see how far we make it. We'll let you know when you're back next week. We'll let you know. Then. But I think we have, and then we say return back because we get the back propagation. But what we could do is we could just optimize it there. We could just optimize. So we could just say optimize. Thank you for the likes. We don't need this self. All right. So many hearts there. Appreciate it, you guys. Thank you for all the likes. Appreciate it. You see those little heart icons floating there on the screen. You can see them. Up there. That's what I see on my screen. Those are heart likes. So we're trying the best we possibly can right now, you guys, to Charles de Cruz. Wow. Yeah, we're trying the best we can to create a machine learning from scratch, or deep learning, AI, essentially AI from scratch. It's been a couple years, but we're trying our best. So let's see if we can optimize back, and then we say optimize, and then but we need the weights. We need the weights, self.wei weights, and then the back propagation, and then I don't know. Hey, Steven, how's it going, Sumit? How's it going? Love Python. Charles, yeah, Python's pretty great. I like it. It's fantastic. We're trying the best we can to make this work. We're trying the best we can to make it work. Steven, hey, all good. Thank you for the likes, you guys. No worries to me. Always got to spell. Spelling is a thing with a different letter, A versus E. A versus E. You got it. All right. How do we optimize? I know we've got a learning rate. So we got a learning rate. Hold on. Learning rate. I know we need to multiply that. And then we need to have a derivative, or a delta, right? Delta. Oh, so we do need the delta part first. I forgot. So we've got the output, and then we need the delta. Delta. Thank you for the likes, you guys. Delta equals C underscore out minus Y, I think. I think that's it. I think that's the part we need, is those two things. All right. Does my program still run? Python ML. It does. It still runs. How is that possible? I don't understand. All right, cool. I'm glad it still runs, but we've got delta, print delta. Here we go. So what we need to do is we need to see how wrong the AI is. So let's see if we get the print delta. Is that going to work? It is. It is working. Okay. And it's working really well. It's working very well. Check it out. Okay. This is great. Okay, so that part's good. So we know we're on the right path here. We're on the right path. Okay, so we need to do backward propagation next. So we've got our output, we've got our delta. So we know we're good up to this point. We know we have good data up to this point. Here's why I know that, because the answers are through the training data up here. So go up here. So we know that the answers are here, right? This is the actual answers, and then this is the result of the answer right here. This is what the AI model thinks is the answer. Obviously, it got it wrong. It got the first one right, perfect, but that's a given. It's a given because this is an XOR operator training model. And then the last one is wrong, but the middle two are also close enough. And so you can see that it's giving us a delta. So it says that the expected value for the last element is supposed to be 0, essentially. But as you can see, because you can see here, the expected of the last element is 0. But it's not, the model did not give us 0 output here. And so the delta, how wrong the model is essentially 100% wrong for that last item. So this is the delta. So now that we have the delta, we can go a step further. Next step, we need to do the back propagation, and we need to optimize. So we're going to do that all in the same rate. All right, so we've got our, I guess we got our params. I guess our params is good to say, or weights, maybe we could say weights. weights, and then our derivative back. So this is a back propagation. So we need the, how do we do this? How do we pass in our data, our next data? So I guess this would be the delta. The delta, is that what we need it to be? I think it needs to be I think that's the delta. I could be wrong, you guys. I could be wrong. It's been a while since I remembered this, but we're gonna give it a try. We're gonna give it a try. All right. So backwards. So here we go. We'll do cout dot back, and then we specify the delta like that. I think we do that. And so that is the, but then we need to capture the output here. So C back. Here we go. I think C back is good. C back works like that. And then we copy and paste that. And we do B and then A. Although we don't need to capture this last one, I don't think. B, A, like that, right? I think, you guys, is this right? Or wait, no. Not C. I think we have to do this. There we go. Like that. There we go, you guys. Making a free command for BSD isn't a huge task, but nobody does it. After spending the whole day reading forums, I realized the real challenge is not building at once, but maintaining it over time. You got it, MD. That's actually the whole thing about computers in general. With data and software, is sort of things are moving and things are changing. So maintaining it becomes the largest task for everything. Always, you guys. Always. What are we trying to do here? Good question. We're trying to build from scratch our own machine learning framework today. That's what we're doing. It's a hard mode task. And trying to remember all the things, because it's been a few years since I've done this. So it's always good to, get back up to speed on things that you've forgotten. So that's what we're doing. Today, we are writing a machine learning framework from scratch. We got pretty far. Just create an array which holds all the outputs, and then you can do it on backprop. Okay, cool. So I do have my output here. I'm saving my output on the forward. So each of the layers has its own output section. So you're right. Okay, so we have the output here. I don't need to save it extra. You're right. I don't need to save it extra because I already have the output. I'm saving it here. So we could. What are we trying to train it for? Oh, we're gonna make it really simple. We're gonna try it for XOR operator. So the XOR operator. There we go. That's what we're gonna do. We're training it for XOR operator. Save. Right here. So it's really simple. So that means it's really easy to validate that the model actually works. This is like how you doing, subject of AI? Hey, your name. Guess what, subject? Thank you for the likes, you guys. We're actually we're doing some AI today. Thank you for all the likes. I appreciate it. Yeah. So we're doing good. Subject of AI. And we're trying to train an AI to learn the XOR operator. That's what we're trying to do. But we're going to do it from scratch. We're not going to use any. We're going to use a few things. We're going to use like the import. We're going to use import for NumPy. And thank you for the likes. You guys appreciate it. See the little heart icons show up there on the screen. See all the heart icons there. And so we'll do the best we can. We'll do the best we can to make it a thing. That's what we're going to do. But we do have to get going at a certain point here. We probably have about 20 more minutes left. We've got about 20 minutes. So we'll see how far we get, you guys. Thank you for all the likes. I appreciate it. We're doing something very hard today. It's very hard. And I'm struggling, you guys. I am struggling. So we don't actually, who said this? We don't actually have to, Dabber Coding. Hey, Dabber Coding. Thank you. Just create an array which holds all the outputs. We could totally do that. So we don't necessarily have to do it like this. We do have the delta, right? And we can do a mean squared error. So this is the delta. And then I know there's like how do we do a mean squared error? I know we need to do that here, right here. This is where the mean squared error has to happen. What epoch and how does it help? Oh, what's epoch? Okay. So epoch is really simple term. It's just number of iterations on the full data set. That's all it is. It's just how many times are you going to train a model on the complete data set. So you can train a model on individual training samples. So say here, we've got 4 samples is what we have here. We've got 4 samples. You can see 4 samples of training data. Wow, thank you for all the likes, you guys. That's what epoch is. It's just how many times are you going to train it on the complete data set, itself. And then the learning rate is just based on the delta, how far off the data is. You can apply a learning rate. So you times learning rate like that. And then you can use that to apply during back propagation to the weights to slowly adjust the model. So that way it tunes, it finds the ultimate answers to all your questions. You guys, thank you for that. Yep, epoch versus batch. Yes, epoch versus batch. Okay, so that's actually a good point. So a batch can be just however, this is like a single batch. We're doing one batch, but we're doing 100% of the data is the batch in this case because it's a simple, we're keeping things simple today. We're keeping it simple, you guys. Nice. Recently been developing with TensorFlow neural networks. TensorFlow is a fantastic framework. It is excellent. It makes it easy, especially if you use Keras. Keras on TensorFlow is great. Keras on TensorFlow. I love it. Dabber coding. And don't forget the income gradient. For updating the weights is different than the income gradient to the next layer. You'll end with 2 gradients. Okay. Thank you for reminding me. We'll try the best we can. It's been so long since I've done this. It's been so long. It has been a while. So this is the hardest part, is the back propagation and the optimizations, the actual training phase. How frameworks came into being. We realized that we're repeating a lot of the code, and we needed to, and a lot of people are repeating a lot of the code. And so a framework becomes really valuable to place code that a lot of people are repeating. And so that makes it so they don't have to repeat the code anymore. They can just use the framework. It becomes a common worldwide pattern that everyone uses. And the framework should only cover the common pattern parts and then leave everything else up to the developer to add customization after. I think that's how you can answer how a framework comes into be. That's how a framework comes into be. But we're kind of building it a framework right now because this is a common pattern that everyone uses. I'm not sure how far we're going to get, guys. I'm not sure how far we get. But Dabber coding, you definitely know your stuff. You absolutely know what's going on. So we've got our delta. Let me see here. So, let's see. Delta. Okay. How do we, okay. So we need our delta. We need our gradient, and we need to apply the gradient to the weights. So we've got our weights. We've got our back, or our data. And then we've got the delta. So we've got 3 variables. We've got the delta, the weights, and the back. How do we do this? We don't need to do this yet, right? Do we do this part or I've completely forgotten. How all this works. I need help. Why are we performing product of data with weights before performing derivative and back propagation? K7? Because I don't know what I'm doing. It's been so long since I've done this. I started the stream like, we're going to figure this out. There'll be no problem whatsoever. And then I came into a situation where I definitely don't remember. Okay, so we've got our delta. Our delta's here. I don't think we do delta there. We don't, all right. Okay, so you're totally right. So do we optimize first? No, we have to get the back propagation first. Actually, I don't know. TensorFlow has classes to generate new data dynamically. It makes it way easier. TensorFlow makes it way easier. Async, append parent, set child chain. Wait, sequence K? What? Op edits. How's it going? Welcome on in. We're struggling to figure out how to remember doing a back propagation. It's been so long since I've done this. It's been many years. And I've forgotten. And I'm trying to do hard mode where I'm just trying to pull it from memory, but I think we hit some roadblocks. That's what it is. That's the situation we're in right now. But we'll see how far we get. We've got a few minutes left. We got about 10 minutes, and we got to get going. We got about 10 minutes left, so we'll see if we can make any progress on this last 10 minutes here. So we've got our delta and our learning rate. So we've got our delta, right? So at least we have that part. We have the delta. We know what this is. And then but do we need to do a mean squared? I remember we have to do mean squared error on this part right here. So how do we do mean? Oh, I guess we could MSE, which is it just takes all the values and then does an average on it. But do we need to? I think we need to, but I can't remember about that part. I don't remember, you guys. Your live captions are failing. I know they do that. They do that sometimes. They fail. They fail funny. They do. Yep, you're right. They get it right about 80 to 90% of the time. About 80 to 90%. But when I speak too quickly, then they struggle to keep up. They struggle to keep up when I speak too quickly. Here we go. Okay. So I know we at least have this, so I know that part works. And then let's see if we can do one propagation backward. Let's see if we can do one. So we've got C back, which we need to keep, I think. And then we get C, which is our output layer. We're going to do backwards on the delta, which is our training result. So at least I know that part's right. I feel like that part's a good part. Okay, so we've got our delta. Delta tree, CY. Wait, thank you for the likes, you guys. Del tree. What do you mean del tree? What is del tree? Oh, is that what it was saying? Delta versus del tree. I got it. Okay. Some just use single value for MSE instead of for MSE. Instead, you use batch. Just use single value for mean squared error. Instead, you use batch. Got it. So we should do LOL. That's DOS, just denial of service. Is it sequence K denial of service? All right, how do we do this? I kind of I need to go look. I need to look this back up. I do need to look this back up to get the exact. But I feel like okay. So to optimize, we just need to subtract the weights. So we've got, let's just do layer like that. And then self, and we can pass in self like that. And we go self dot weights, weights. And I don't even have the bias in this. WEIGHTS, there we go, weights. Man, I am so behind on this AI stuff. I just crunch numbers in C and do a lot of GNU plot. This is like sorcery to me, huh? Don't worry, it is to me too. Entropy, don't worry, it is to me too. These are like crazy incantations that make it. Forward passing is easy, but when you get into the backward pass and the actual training process, then it gets challenging and tricky. Trying to remember all the things that we need to remember. So weights minus equals. I know we have to do that, and delta on the learning rate. I think, but we're missing something. We're missing something here. We need to do, I think we need to do the derivative somewhere. We haven't done the derivative. And we only need to do this for the backward propagation backwards. See, I'm missing part. So we've got the delta, but don't we need a password that, see, this is where I need to start. I need elint delta all day. Is it? Elint delint. Hey, how's it going? Chidu. Hey, Ro, welcome on back. Happy to see you. MS-DOS, Microsoft denial of service. What is disk operating system, right? Disk operating system is what I think that stands for. Optimized function should subtract the delta from weights, right? Yeah, so we've got the delta and the learning rate. So we've got this, and we might only need to, so we've got that. And then the part that I need to remember is how to go to the next phase. How do we, so we've got the delta here, but we've got the delta there. How, let's see here. How do we, this is the part I just don't remember. I just don't remember at all. I don't remember this part. So we have the inputs from the outputs in previous, so we don't need to worry about that. But we do need to do backwards here. Optimize function, yep. Okay. Oh, right. We only have 4 minutes left. I don't know how far I need to like look this up. I need to like do some looking up. Let's just, this is like the hardest possible thing. But we'll see here. Backseat print, C back. I don't know if that's going to work. C backwards. Are we returning anything? Return, and then let's see. Oh, we don't actually need to return. Do we? But we do. I know we have to do this. I know this has to happen. So that way we can pass it onward. But this is where I hit my wall. I'll need some help. We'll have to probably do part 2. We'll probably have to do part 2, you guys. But I think I need some help. All right, so let's zoom out here. All right, let's redo this. Help with back propagation and optimization. Quick examples in Python. We need to see this really quick. We need to see it. All right, we need help. Here, okay. So this is going to help us out a little bit. It's using sigmoid, learning rate, find forward propagation, output layer. Okay, here's the dot. Okay, so this is our, plus bias. Okay, so I don't have a bias right now, but we need to add that in later. Damn, the math is strong. It is sequence. It's it's crazy. Math is crazy. So then we activate it. Okay, so we've done this part. We're actually done in this part. Then we got the error, right, with the predicted output. So we've got the error. Let's do I'll update. So delta. I call it delta instead of error. So I called it delta instead of error, which is fine. We don't need to worry about that. And then we need to calculate the loss. Okay. So here we go. We can do this. We can do mean squared error like this. Let's do it. Let's calculate that. I like this. We need to do loss. All right. Loss like this, but we call it delta like that. And then, so we calculate delta. Here we go. Delta like that. I'm going to do forward like that. Forward. All right, so we're getting, what's your loss function? It's mean squared error. Oh, there it is, right there. Here you go. Mean squared, very simple mean squared error. And then, so we're looking stuff up, but we're not using AI. Well, actually we are. We're using AI right here. What do you mean we're not using AI right here? We are using AI right here. But we're implementing it in our own way. Dabber coding. Since you're using matrix multiplication on back propagation, you must do the same. Absolutely. We absolutely have to. I totally agree. But we also have to transpose, right? Don't we have to transpose as well? Is there any transposition? There is. See, there's the dot T here. I forgot about transposition. So we need to calculate gradients and predicted output sigmoid derivative. Okay. So this is very helpful. I'm going to copy and paste this so that way we can refer to it. We're going to copy and paste this, and then we're going to implement. How did it know? Wait, hold on. How did it know this is what we were doing? We didn't even mention XOR operator. How did it know? You guys, this is crazy. There are 3 hidden layers from randomization for building an LLM. Sequence queue. For an LLM, you want more than 3 hidden layers. I think like ChatGPT 3, right? GPT-3 had like 92 layers, which is a lot. 92 layers, you guys. That's a lot of layers. That's a ton of layers. So we don't need that many layers. And there's also a dramatic diminishing returns. Google telemetry. Wait, what do you mean by Google telemetry? What is that? What do you mean? All right, pb paste reference.py. Let's put that data there. So now we can always refer back to it by reference. So here, now we've got everything here, so we can easily see it in our terminal window. All right, so we hit a roadblock. We needed some help to look it up, but we're still implementing it on our own. For the most part, you guys. So we're over time, but I kind of want to see if we can get a little bit further on the back propagation. Can we get a little bit further on the back propagation? Let's see here. Okay, so we've got our loss, and then we need to back propagate gradient of loss respect to the output of the predictions. So predicted output, right? So we've got this. We've got our predicted output, which is out C. This is in our code over here. It's out C. It's right here. That's what our output is. And so we create our delta or our error, and then we create our loss. The last brain cell. You got it, Pichu. You got it, Pichu. How do I learn deep learning in Python? Thank you for all the likes, you guys. That's what we're trying to do right now. We're trying to do deep learning from scratch for the most part. So if you go back to the beginning of the stream, we started with an empty file, and I think we did pretty good. You guys. We went to the beginning of the file with an empty file, and then we filled it in. And now we're trying to do back propagation, which is the part of the learning part, right, where the AI learns, and that's what we're trying to do right now. We're trying to do the learning part of the AI. So here we go. I wonder if I can optimize the layers, operate in order to dial back hardware stress. You can. There are ways to do this. You can, especially when you have like a GPU. Like we're doing CPU training right now. We're not doing graphical processing unit training. We're not doing any special advanced hardware accelerated training. But you can sort of do a fused kernel, which I've done this before in the past, where you merge multiple tasks into a single step within the GPU layers, which makes it a lot faster. They use this strategy. It's called flash attention. It's called flash attention, but all it is they just merge multiple tasks into a single GPU step, such as like activation and the forward pass all in one. Like they do like that. Bro, every concept in CS, you are a giga Chad. Pichu, I'm trying. I know the things, but you always have to remember them later in past, and it's always a challenge. So I remember the concepts, but applying the concepts, there you go. Now there's the challenge. That's the part that we're struggling with right now. That's the part where Pichu, yeah, you got it. You got it, Pichu. We're gonna try. We're gonna try our best. Okay. So we've got our loss. Let's go over here. So we've got our loss here. Thank you for the likes, you guys. Thank you for all those likes. Now we need to do this part right here. Predicted output via the D gradient. All right. So we need to calculate the gradient of the loss first. Okay. So this has to happen first. We need to calculate the gradient of the loss. We have to do that first. So if we go over here, let's see. Oh, I didn't even copy and paste it, did I? Let's do that. Let's do F2, function F2. There we go. Let's bring that back over there. So this is what we want to do. We want to do this. We need this. Oh, and then the derivative. So let me just pipe this over here. Thank you for all the likes, you guys. Appreciate it. And we got our predicted output. So we got our predicted output, which is going to be, I don't know. That's why we have AI. I know, isn't it? I know. Next step is to do it in Rust using Burn deep learning library. You know what? July. We should totally do that, shouldn't we? So they fine tune the hardware pipeline. You got it, Sequence K. I don't know if you I'm calling you Sequence K. I don't know if that's actually what your name is, but Sequence K sounds July. Or you should see the MSE derivative formula, mean squared error derivative formula. Okay, let's double check it. Let's double check. Do we have to? We don't need MS. We just need the loss. We've got the MSE right here. We've got the mean squared error, and then we need to get the output or the output from this part. So we've got the derivative. Which we have. So we got self dot derivative. We've defined that up here. We've defined it right here. Here's the derivative. It's just lambda. It's a tan h is the derivative. I'll keep an eye out. Okay, you should see the MSE derivative formula. That's what we're doing now. That's what we're doing next. Dabber coding. That's true. Not anyone wants to know all the stuff, which just like magic behind the frameworks such as PyTorch and TensorFlow, and you're trying to do it well. That's what we're trying to do right now. Dabber coding. We're trying to do all the things that PyTorch and TensorFlow do. They do for you. We're trying to do all those things for it automatically. We're trying to make it happen here. So we've got our out or D underscore out. Here we go. Let's see here. So self.derivative, and then our predicted data. So our predicted output, which we have this here. We have self.output. We have self.out. So that's that. But I don't think we can keep doing that. I don't think that works. I think we have to do something else there. I think we have to do something else here. Let me take a look. Weights O np ... hidden layer output transpose. We have to do transposition. We're gonna run out of time here, you guys. We're gonna run out of time. Let's see if we can get it just a smidge further. I just want a little bit further. I want it to go a little bit further. Weights output. So this is when we get weight gradient. But where do we do the optimization? Where does the optimization occur? Okay. Here's the optimization. So it's doing all the back propagation first. That's actually interesting. So we could do that as well. I like this approach. It's wasteful, but we can do it. I like this approach. Okay, let's try to do this. Let's try to make it do. I like this. So what we're going to do is we don't need to do the optimization right here. We're not going to do that. We're going to we'll do self.gradient. Here we go. So we'll save that. We'll save that there. And then it will look like this. There we go. Redo. Hold on. Where is that? Where'd it go? Wait, hold on. We're self.gradient. Perfect. Self.gradient. But I don't want that. I want this. Self.gradient is going to be this. Here we go. All right. Perfect. Copy and move this up here. Okay. So it'll be that. So there's the gradient. So we need to, oh wait, that's not even, wait, is that the gradient? It is. Gradient of the lot. Okay, yeah. Let's see. 1 second. Thank you for relaxing, guys. I wonder how good is TensorFlow contrary to Python? TensorFlow JS. It might try things with JavaScript if it is suitable. You should. It's actually totally fine. You can totally do it because they both support hardware acceleration. TensorFlow JS supports accessing the GPU, so you'll be perfectly fine. By far. Dabber coding. By the way, the derivative of the loss function is incorrect. Since the MSE uses square, the derivative must be. Wait. Use squared, the derivative must be. What? The optimization is minimizing the loss function. Calculating the gradient of the loss function, you get the direction of maximum growth. Oh, so you multiply minus gradient for learning rate and sum to the weights. Got it. So this helps train more quickly and more accurately. July Ort, that sounds right. You're saying things they're saying things. Dabber coding, -2 times target predicted out times gradient, out gradient. Dabber coding. Okay, so times 2. Got it. I kind of understand. I kind of get it because I've done a lot of different. This is actually really interesting. If you've done these Dabber coding, if you've tried varieties of algorithms like this, you'll find out that AI models are very forgiving. They're very forgiving. Sequence K, you know what? Oh, times 0 though. Times 0, random times 0. It's just going to be a bunch of zeros. You're just going to see an array of zeros. Import random, print random.random. That'll just be zeros, you guys. Minus the gradient is the direction of the maximum growth. Yeah. So that is. So we want to train the model, and then we want to give it the best possible chance of learning, but we don't want to overfit or underfit in ways. There's a whole bunch of strategies. But here's what's really interesting. Even though you might mess up your algorithm, like you might mess up the bias or you might mess up your loss function, it still works. Best random generator ever. So even though we're doing it like this, it'll still work. Isn't that crazy? It'll still work. You can do all sorts of things and it will still work. We'll have to show you. So we do have to get going here, but I want to try just to get one back propagation going. I just want to get one back propagation. So self gradient, self.derivative, self output, and the delta, which is the error, and that's going to be the loss. Let's double check. Did we get everything right there? Predicted output, calculate the gradient. So this is the gradient that we want here. So we want to calculate this. Let's double check that we got it right. Let's double check. Here, what we're going to do is we're going to just close this pane. How do we close this pane? Like that. There we go. Now, let's bring this in here. All right, like that. So this is what we need to make sure we got right. All right, so our gradient, so we're going to make a gradient for each of our layers, and then we're going to get the derivative. Okay, so derivative of the predicted output. Oh, okay. So like this. And then, so there's the output, but then this is the delta or the loss. We're going to do loss here, right? Do we do loss here? Self backwards? Let's double check. Self backwards. We need the final output. We have the output and self output. We have this. We have that here. We have that here. So, error times. Ooh, really? Okay, so loss times. So that kind of matches up with the algorithm there. So our gradient is going to be the loss multiplied by the derivative of the output. Is that right? Does that right? That feels weird. That feels weird to me. Here, let's go over here. No, let's not. Let's do a like that and go vi. What is it? Reference. Here we go. Is that right? All right. So we do have to get going here. All right. But I just wanted to. So we don't need to worry about bias right now. We don't need to worry about bias. We don't need to worry about the bias yet. We're not using bias right now. We'll get to bias later. Output and the gradients. Oh, gradients. Equals directly. Oh, okay. So this is going to be used here. Okay. Just trying to understand some things, you guys. Just trying to figuring these things out. So there's a transposition that occurs here. Gradient of loss with respect to the output layer weights. Okay. I'm lost. I don't understand what you're using the loss function. Oh, as a loss function? So you can just it's actually really simple. It's just mean squared error, MSE. And this will work. I know this works because I've done this a few times. So with loss, maybe loss here. Do we want to do loss here? Is that what that is? Because that's the error. And then are we doing it with the error? So output prediction error, right? Okay. That gives us the gradient for the layer. So at least we should, and then we can return it if we want. We can return it, but we don't need to. So we'll just say backward that, and we'll just say c.gradient. All right, let's see if that works. Python AI, ml.py. Okay. We have an error. Let's see if we can fix it really quick. And then this will be the very last thing that we do, and then we'll have to resume this. We'll have to resume this on Monday. We'll have to resume on Monday, you guys. That'll be the plan. We tried really hard. This is a hard mode stuff here. We're trying to do everything that's done in sort of the TensorFlow and inside of PyTorch. We're doing from scratch. Now, Cybercube, hey, how's it going? Bro, what's the difference between NAT, which is a network address table, and bridge? I'm learning networking, which should I use? Network, sort of like a NAT is like a lookup table that just maps, I believe, inbound requests to different IP addresses on your network. But a bridge, I guess, is more of a router. It's more like a proxy, which it's different. So I think you can use IP tables for the NAT, right? Is IP tables a NAT? I think you can use IP tables to specify rules that can set up different things on your operating system. But a NAT versus a bridge, yeah, I think a bridge is going to be more of like a proxy, and a NAT is just going to be a routing table. It's just a routing table. NAT is easier. I think a NAT is easier to use. Sequence K. I'm not used to this much calculation with undefined variables, but I barely use Python. JS is second nature to me. It is. JavaScript is pretty sweet. I got to say, JavaScript is pretty excellent. Keep doing these things. This stuff's all right. We'll make it. I love IP tables. You do? Show do? Show do. Hey, yes, excellent IP tables. You can masquerade connections and make a proxy in the kernel. You totally can, can't you? You can do anything you want with IP tables. You can totally take over. Table equals DHCP, kinda. Yeah, DHCP also assigns an IP address to your MAC address, so it can bind a MAC address. and your router. It can take a MAC address and give it a local network address, and then it uses a NAT to take the local address where data is coming inbound, and then map it to your local your device on the Wi-Fi, right? Very low overhead, super easy. It is. IP tables is awesome. You're totally right. Love me some IP tables there. All right. Let's see. I want to fix this error, and then we have to call it, you guys, because I have a hard stop that's coming up here in 10 minutes. And I wanted to be done before then to get prepared, but I got a hard stop at 1 o'clock today. A hard stop, you guys. But let's see if we can fix this one error. Layer object has no attribute derivative. All right. Did I just misspell it? Oh, I never said it. I never said it, you guys. Here we go. Derivative. Here we go. There we go. Is that fixed now? Is it all better? Is it happy? It is. It's happy. Check it out. Okay. So we did our back propagation. We've got our out, right? So we got our gradient there, our back propagation gradient. We made progress. We're making progress. 100%. You got it. 100%. Table DHCP kinda. 100%. Okay. So we've got our gradient, which is great. I'm actually kind of excited about that. So we've got our gradient. Perfect. And then I want to do one more. Let's go one step further, you guys. Let's go one step further. Reference. Okay. Hidden layer. So this is the next one. So, but I'm actually curious. Hold on a second. Wait a second. I know we need to do this. I know we have to do, wow, this is a lot here. This one line is crazy. And then we have to transposition X, which is the input. Oh, I forgot. Did we save the input? You guys? I don't think we did. We have the output. Self.input equals input. Inputs. Here we go. Okay, I forgot. We got to save that. So we got to save that. So we got self.out, and then we've got our inputs. So that way we can do back propagation. Okay. This is what I was missing. This is what I was missing earlier. This is why I was getting confused, because we need that input information. So then we can do some extra stuff. But you know what? That's basically as far as we can go today. We'll have to try more on Monday. You guys will have to try more on Monday. Thank you so much for hanging out today. I do have to get going and get ready for the next upcoming thing that's happening right here. I got to do some other things, but it was great spending time with you today. We did some machine learning, at least the beginnings, from scratch, kind of from scratch, because you can see we used one library. We used the NumPy library, which helps us with some of the common iterations and loops. It makes it a little bit easier. Is this a repo poll project? Noticing not a lot of import. Yeah, because we're trying hard mode. Sequence K. Thank you. Yep, we're headed out, you guys. Thank you so much for hanging out. Dabber coding. That's what I said. You must save all inputs and outputs. You did, Dabber coding. You did. You were totally right. And it was like, I'm like, where's this? Like, I'm trying to think. You were right, Dabber coding. I'm like, I'm confused. Like, I'm missing something. I know something is missing. And it's like, oh, this whole time I was like, oh, I forgot. I got to save the inputs and the outputs. I forgot about the inputs. K7, thank you so much, Stephen. Learned a lot. You did. Thank you. Joe, thank you for hanging out today. Thank you. Take care. We're heading out, you guys. Appreciate for all your time that you spent here. We'll be back on Monday. Will you push it to GitHub? Sure. Let me do that really quick. So I'll push this to GitHub. All right. See. Hold on one second. Git status. Git init. We're init. Here we go. Git add. We'll do ml.py, and then we'll add the reference, and we'll add hello. Why not? Let's do that. And then we'll do git commit -a. We thank you for all the likes, you guys. We'll push it to GitHub here, and then we'll put it on our Discord link. Git-am. We'll call it initial ML project from scratch. There we go. And then let me create a repo real quick. Let's create a repo. Let's go over here. We will call it GitHub Steven, and then we'll create a new repo. New repository. There we go. Creating a new repository for you guys. We'll call this Python ML from scratch. Kind of. There we go. Kind of. There we go. Thank you for the likes. We try to build a ML framework live on stream. There we go. And see how far we get. There we go. And then we can also put a smiley face in there. Why not? Why not? It's a public repository. We'll make me the owner, and then we go create Git. All right. Then we'll push it over here. We'll push it, copy paste that over here. We go. Boom. All right. Now it's live. And then we'll copy this link into our Discord. Here we go. It's live on our Discord now, you guys. Dabber Coding, can we contribute on that? You absolutely could. Drawing Brothers, hey, how's it going? We're just wrapping up stream here. Get skill on point. You got it, Sequence K. We know how to do git push. So we got it here. Python ML from scratch, kind of. It is live on our Discord. In case you don't have our Discord, I will copy and paste that over for you real quick. Here is our Discord. Let's paste that in. Pasting in the Discord. All right. Redundancy. What do you mean? Our subtitles is getting confused. This is like question mark. It doesn't know what's going on. Here, we'll fix that real quick. There we go. Now it's good. It knows what's happening. So there you go. There's our Discord join. But we'll be back on Monday, you guys. Feel free. Here we go. So here is our repository. How far did we get? We got pretty far. We got a layer, and then we did our initialization. We've got our activation and derivative. We do have a bias here, but we didn't use it. And then we have our forward propagation, which we did correctly. I know this part because the easiest part. We did this part and we did it perfectly. And then we have our forward pass with all the layers. And then we went through and then we started doing training. This is the training phase, but we don't have everything we need. We need to fix this part right here. We need to fix the backward propagation, gradient generation, and the training aspect, which is the optimize, right? The optimize is really just the training. This is just the training section. So that's what we'll do on Monday. Feel free to pull the repo or do whatever you want. Pull request welcome. Thank you everyone for hanging out today. We're going to end stream here. Thank you for hanging out. It was a lot of fun today. It was a challenge. I got to tell you, it was tough. We did make a lot of good progress though. We did make really good progress. Thank you so much for hanging out. We'll be back on Monday. See you guys.